Solve the equation on the interval from 0 inclusive to 2 pi non-inclusive. The equation is sine of 2 theta is equal to negative square root of 3 over 2. Alright, couple things we need to discuss here. First off, we want to go ahead and use a substitution, and we're going to take this 2 theta and we're going to let alpha be equal to 2 theta. Which means that I can now rewrite my equation as the sine of alpha is equal to negative square root of 3 over 2. And now we're going to use the properties of the unit circle in conjunction with the fact that we are limiting ourselves to one full revolution of the circle, or one period of the sine function from 0 to 2 pi. So that means our lower limit is going to be 0 inclusive, and that's because of the bracket, and our upper limit is going to be 2 pi non-inclusive, or not included, and that's because of the parentheses. So the next thing that we want to do is go ahead and look at our unit circle and figure out where the sine of alpha is equal to the negative square root of 3 over 2. Now you should have the unit circle memorized, but we'll go ahead and we'll use a copy of that just to refresh our memories. So here's our unit circle. And remember, this is going to be our angle alpha, and that's what this is going to be keyed upon. So we want to know what alpha is when the relationship of y over r is negative square root of 3 over 2. So we know that y is negative in the third and fourth quadrant. So we'll be down here in quadrant 3 and quadrant 4, and we'll look for negative square root of 3 over 2 in the y position, which is going to be this value right here, and it's going to be this value right here, which means that alpha is going to be 4 pi over 3 and 5 pi over 3. Now what we want to do is understand that since this is a double angle of 2 theta, we also want to go ahead and say simply that alpha is going to be equal to 4 pi over 3 plus, and what we're going to do is have 2 times some k pi. Now another way of writing that would be k times 2 pi, where 2 pi is going to be the period, and k is going to be some integer. That's what that z stands for. We also want to write this as alpha is equal to 5 pi over 3 plus 2k pi. And what we're doing is we're going ahead and using this form so that we can encompass all values of alpha no matter how many revolutions we go around the unit circle, whether it be in a positive direction or a negative direction. And now, since we've used the substitution alpha is equal to 2 theta, I'm going to replace this alpha with 2 theta. I'm going to do that over here also. And now we go ahead and write out that 2 theta is equal to 4 pi over 3 plus 2k pi, or 2 theta is equal to 5 pi over 3 plus 2k pi. Now since this is 2 theta, I want to divide everything by 2 because I'm just looking for theta. That's all I want. Okay, so we will go ahead and divide everything by 2. I'll divide this by 2, I'll divide this by 2, and I'll divide this by 2. 2 theta divided by 2 is just simply theta, and 2k pi divided by 2 is simply going to be k pi. But what is going to be 4 pi over 3 divided by 2? Well, if I divide by a number, that's the same thing as multiplying by its reciprocal. So I'd end up with 4 pi over 3 times 1 over 2. The 2 in the denominator will divide out with a 2 in the numerator, leaving me with 2 pi over 3. So that means theta will be equal to 2 pi over 3 plus some integer multiple of pi. Now we're going to do the same thing to the 2 theta equals 5 pi over 3 plus 2k pi. I'm going to divide everything by 2. In this particular instance, I get theta is equal to, and this is going to be the plus k pi over here. Now, 5 pi over 3 divided by 2 is the same thing as 5 pi over 3 times 1/2, which is going to give me 5 pi over 6. So now I have two possibilities, but I need to know everything or every possible theta that falls within that interval from 0 to 2 pi. So what I want to do is go ahead and let k be equal to 0, 1, and 2, just to start with. It could be more. I could be using 5 and 6. It depends on what I end up with for an equation. So I'm going to substitute k equals 0 into this thing. I'm going to substitute k equals 1 into this thing and k equals 2 into this thing and see what theta ends up being. Okay, so let's go ahead and plug k equals 0 into this thing. And what we're going to end up with is theta is equal to 2 pi over 3 plus 0 times pi, which is just simply going to be 2 pi over 3. So I know that that's one of my possibilities because 2 pi over 3 definitely falls within this interval from 0 to 2 pi. Let's do the same thing for the second equation. So we'll have theta is equal to 5 pi over 6 plus 0 times pi. Once again, that shows me that theta is simply equal to 5 pi over 6. That works because it also falls between 0 and 2 pi. So let's try, and let's put this here as k equals 0. Let's try k equals 1. So theta will be equal to 2 pi over 3 plus 1 times pi, which means that theta is going to be equal to 2 pi over 3 plus 2 pi over 2. Actually, I'm sorry, that should be 3 pi over 3 because I wanted to find a common denominator. So theta is equal to 2 pi plus 3 pi is 5 pi over 3. Does that work? Yes, because it falls between 0 and 2 pi. So now we're going to try it over here. We'll have theta is equal to 5 pi over 6 plus 1 times pi, and therefore theta will be equal to 5 pi over 6 plus 6 pi over 6, because I'm trying to find a common denominator, and therefore theta is equal to 11 pi over 6. Now, we need to make sure, does this work? 11 pi over 6 does fall between 0 and 2 pi. And one of the ways that I'm going to know this is simply, look, if I write 2 pi, let's try that again, with a denominator of 3, that's going to be 6 pi over 3, which means that since 6 pi over 3 is greater than 5 pi over 3, this checks. Likewise, I can write 2 pi as 12 pi over 6. Once again, 12 pi over 6 is greater than 11 pi over 6, so 11 pi over 6 works. Which means that now I need to be looking at the fact that I've got more than just a couple of values here. I have 2 pi over 3, I have 5 pi over 6, 5 pi over 3, and 11 pi over 6. Now, let's try k equals 2 and see if that works. So theta will be equal to 2 pi over 3 plus 2 pi. Well, that right there shows me that it's not going to work, because if I add anything to 2 pi, it's going to be greater than 2 pi. So therefore, in this case, theta is going to be equal to, well, that's going to be 6 pi over 3, that's going to be 8 pi over 3, which is definitely greater than 2 pi, so that does not work. Does not work. I'm going to assume the same thing is going to happen over here. I'm going to have theta is equal to 5 pi over 6 plus 2 pi. Once again, I'm adding a value to 2 pi, and if 2 pi is my upper limit, I can't go beyond that. So this also does not work. But there's one option that we didn't try. What if we had let k be equal to -1? In other words, I'm going backwards. Let's just, for the sake of argument, try that. That means that theta will be equal to 2 pi over 3 plus -1 times pi. So that means 2 pi over 3 minus, now remember, pi is going to be the same thing as 3 pi over 3. So that's minus 3 pi over 3, and that's going to give me a negative pi over 3. Well, let's think about that for a moment. It's a negative value, but is there a positive value or a positive angle that would have a coterminal side with negative pi over 3? Well, yes, it's going to be 5 pi over 3. So it does work, I just don't need to do it because it's redundant. I'm going to try it for the other value, so theta will be equal to 5 pi over 6 minus pi, which is going to be 5 pi over 6 minus 6 pi over 6, which is going to give me a negative pi over 6. And that's going to be coterminal with 11 pi over 6, so I'm done. So what I want to do is put these in numerical sequence from least to greatest. And as it turns out, they are already in numerical sequence, and since this is going to be a set of values, I will need to enclose them within a set of braces. So that's my solution set.